Okay, the first lab for this control laboratory is basically give you some basic introduction on how to use the Matlab to do some linear algebra calculations, and also you can use Matlab to code the system, the control system later. I would introduce that in future labs, and also in this lab you will learn how to use the Simulink to build block diagrams. Rather than you to type codings, program how to use these block diagrams to build a control system. Okay, so both Matlab and Simulink are very widely used in today's engineering, and Matlab is more like a coding approach, and Simulink is by using the block diagrams, more like a circuit schematic. Okay, so here is the basic introduction of Matlab and Simulink. Simulink is embedded in Matlab, so sometimes you can convert the Simulink block diagrams to Matlab codes as well, and you can also use Matlab codes to somehow configure the Simulink block diagram parameters. Okay, so basically what we need to do is for these two lab experiments, the first one is basic Matlab tutorial. If we click on that. And we only need to go through from page 1 to page, I think it's 7 or 8. Okay. So go through each steps, so it will get you know how to use these linear algebra vectors, matrices, and do some calculations to calculate the polys or eigenvalues or something like that. How to do the dot multiplication of two vectors or two matrices, do the multiplication of matrices. What's the difference between dot computations and non-dot computations between matrices? Okay, so very basic techniques of coding in Matlab. Okay, so from page 1 to page 7. Okay, and the next lab experiment is to do the Simulink tutorial. Go through each steps, and it can be divided into two parts. The first part is a very basic one, just single one block diagram. Okay, and the rest of them will be a little bit more advanced, and you will learn how to use multiple blocks to do the control, to build up a feedback system, and how to make a more complicated system. Okay. Oops. So the first 1 to 8, about 8 pages, it will give you the basic from inputs to single one block function block, and the output is the scope. Okay, so you will run the simulations with a step input or an impulse input, and see the step response or the impulse response of the system. Okay, and this system can be either built up through transfer functions or through some other ways. Okay, so this is just very simple, the very first simple system. Okay, just single one transfer function. Okay, and if you run the simulation, it will give you the response. All right, and this simulation process and also the transfer function can also be configured. Okay, and this is the first part of experiment 2, and the second part is to build up a more complicated system. Okay, with multiple components, different transfer functions, and so on. Alright, this is still part of the tutorial, and the next one is giving you an example. There is a demonstration of building a train system. Okay, where is it? You should be able to see the content over here. All right. The train system, it will give you some more practical problems and how you convert the practical problems into a mathematical equations, and how to convert that equations to the block diagrams. Okay, so by following through this tutorial, you should be able to get some idea how to use the Simulink to build up a system. Okay, so basically that's what we need to do in this lab. Pretty simple and straightforward. And what you need to do in this lab is to following through these tutorials and also make the screenshots for each critical steps, like the input, the block diagram, the codes, the system output. Okay, and paste these screenshots in your post labs. Make sure you use the post lab templates and name the post lab as required. All right, and also in the end answer these questions. All right.